The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning to wherever you are in the country. It's Mark from SolidCAM, and we'll be doing today's SolidCAM Live. With me, as always, is Kevin Rankel. How you doing, Kevin?
Good.
Great, and I see a couple people there in the list. So this is SolidCAM Live. We're doing this now during this this period of time just to see if we can help out a little bit with obviously what's going on in the world. And it is a half hour of free training for those of you who have not attended before. Any questions you have now, let's see if we can get to them in today's session. If not, I'll just take note of them and we can go through them in follow-up sessions throughout the week. We'll be doing this until I believe it's the 1st of May. So I do have some topics that we can cover today if nobody has any questions right off the bat. So I'll just take a quick look at the questions panel. In your GoToMeeting, GoToWebinar section, I guess there's something called questions or something like that. You can put in a question, and then Kevin and I will take a look at it once you can, and we can see if we address it right now. But if not, the topic I wanted to cover today was the different options you can find in the Solidverify section. So I'll just get started, and if any questions pop up, Kevin will let me know if there's anything in there.
Yep.
So we're looking at a part now, and you guys are probably familiar with this part from some of the videos that either Kevin has done or I have done, and it's just a really curve-heavy part. And I chose this really to show off just the kind of stuff that you can see inside of the Solidverify. So let's say, for instance, we choose maybe just at random one of these HSR toolpaths. And in our simulation section, you got a couple of different options here. The one we'll cover today is Solidverify because it's got a lot of different functions in there just to troubleshoot your part, check for gouges, check for remaining material, clearances, whatever you're looking for. And you can see right away, if I haven't used the simulation at all with this part, or maybe I did a CAM part cleanup and I cleaned up any models that were in the background, it has to recalculate the previous toolpath to show me the resultant stock. And then once we get into the part, it'll show me what I'm about to work with this one individual toolpath. If I had selected multiple toolpaths, then it's the same thing. It's just going to show me what the stock looks like before we even start this particular toolpath. There you go. And also I have a fixture defined, so it's actually going to bring that up. There it is. So there's my vise, there's my part. You can see that I've done a couple of HSRs already, so there's some filleting there, there's some scallops. And if I run this toolpath in this one window, you can see that you can actually color code each tool. Either I set it to single color, and once I play on this, it'll actually keep it as that gray color. But if I click this little icon, each tool gets its own color. And these colors are actually assigned when you define your tool. A lot of people don't see this because they're just more interested in putting in dimensions. But in the wireframe versions of your toolpath or in Solidverify, these colors are actually used to differentiate which tool did what. So in this case right here, let's say I run this toolpath, we're going to see that I can see that this tool, tool 4, has done maybe just that little bit right there. This is a rest milling operation. It probably didn't really have much to do to the part, but that little individual color tells me that this tool engaged that surface.
Yeah.
I jump out of here. Let's do one of the more interesting ones.
Nice part with that too, when you have it colored, is since that tool was just doing a rest machining on there, it's very easy to see where that change has been made. Where if it was all gray, it's kind of a little bit tougher to go through and see what has changed when you ran that toolpath through.
Absolutely, yeah. It's a good indicator of not only what the tool has done, but if there is a change, what change that is. So this tool was colored yellow. So that surface comes out yellow, and you can see that I didn't even touch that surface there. This is the HSR constant. I guess that's constant Z, I guess. And because constant Z is not going to touch flat surfaces, you can see that it ignored that one. So it has the original gray color, and each one of those has that nice yellow indicating that tool 1 was used there. Now, since this has already been machined, now we can look at all these guys up here. So if I didn't want to see my vise, let's say I had some unique fixturing and I need to get it out of the way to see my part, I can actually remove the fixture here. So hide and show. If I want to see the target compared to the stock, I can click on show target, and it actually won't see anything because we only roughed out this part. But what we can do is we can right click on the part, the stock, go to stock properties. I can increase that transparency. Actually, let me switch it to this guy here. So I can increase that transparency. And now when I show the target, I can compare. I can see how much material might be left behind by some little scallops. I can see the curvature of the original part. So there's a way to do some manual comparisons. And what I'm doing up here is I'm just changing those visual modes. So right now we're looking at just everything being opaque, just having that render mode. The hybrid mode is where you can see that transparency. If I wanted to see everything in kind of this wireframe skeletal view, and then more of just the skeletal view, but just with the actual kind of filled in of the surfaces there. Your SolidCAM views get carried over here as well. So you can see your coordinate systems. The coordinate system here lines up basically with your Mach 1 position 1. So each one of these is a different view using your Mach 1 position 1 views. Just put that back in isometric. If I wanted to take some measurements, we actually have a measuring tool here, and I believe in newer versions of SolidCAM, and maybe Kevin can comment further, I think this is a little more accurate. We can actually do, is it like, can we choose points?
Yep. So in the beta simulator that is out there, not the Solidverify, but the beta simulation, you can actually measure points just like what you guys do in SolidWorks. So you can actually click on a line, and it will give you that measurement. But it's not going to be in this one quite yet. Yeah. It's still being in the process of being released for everyone.
Oh wait, beta simulator was right here. So this is kind of what Kevin's talking about. This beta simulator, take a look at this. Just because we talked about it, let's see if we can kind of show it. And then, how do we get to that measurement?
It's not out yet.
It's not out yet.
That's what I'm saying.
Oh, there you go.
It's not quite out yet.
I don't have it, but that's the beta simulator that we're talking about. You can access that right below your regular simulation. Let's get back to this window here. And we'll just play through that. Now, we're looking at this starting from the initial stock, and we're milling it down to its first stage. We just done this first HSR just to get the bulk of the material out of there. So there's a lot of material still on these faces. But if we want to check the status of the part, let's see how much material is actually there. In some cases, it might not have scalloped as much as others. I can see the amount of material around the part, and there's actually two ways. One is this guy here. This is just your rest material. It gives you kind of a really go no go kind of gauges how much material is there. You can see that there's no material on that top face, but there's all excess material on all these other faces. There's no real gauge here. To gauge it, you're going to want to use this one here. What this brings up is basically just a color-coded numbered range as to how much material is left. So if I had gouged the material by 4/10, it would show that orange color. If I gouged more than 1/4 thou, it would be that red color. If there's an excess of material of 4/10 or 1/4 thou, then we get those colors there. So when I click execute, basically everything is going to be that dark blue because I left behind 10 thou or 20 thou on all these faces, except for that top face there. That's the final face. So that's why we're seeing that yellow color indicating 0 amount of material. If we go through the rest of the part, we'll actually see that we can get some finished faces. We can see that yellow coloring, that green coloring, and that sort of thing. Okay, quick question here.
Yeah, I think we can save that one for maybe
Okay,
tomorrow.
we'll save that one. Perfect. Okay, so I'll make a note of that at the end. Okay, so let's get to a finishing toolpath. So once I click on Solidverify, it'll calculate the model to show me the final part. So this is fully roughed out. I can bring in my my fixture. We can play through this. And again, color coding showing me what this tool is going to do. So this is just HSM constant Z. Actually, no, this is HSM horizontal.
Linear.
So
or linear. Yep.
This one right here?
It could be either one. I was just looking at the toolpath. Sorry.
Yeah. So only the flat faces. And now if we click on a little execute button, you can see yellow indicating those are now finished faces.
Now, Mark, let's talk about a little bit. So go ahead and open up that stock target comparison again. So what you guys are seeing here is the, anything that is orange is going to be technically gouging. But if we do if you go to the settings and change up your accuracy, and maybe your accuracy of this model is only at 5 thou. You may get some colors bleeding over because how the Solidverify is set to a accuracy of 1 thou, but our stock target comparison is set to 4/10. So it's something you guys got to be watching just a little bit. Is, you know, if you're showing a little bit of orange and you're thinking it's gouging, and it could be or it could be not, just based off of how accurate that model is set to. So Mark's got it set at 1 thou right now, and the 1 thou is good. In some applications, we may want to ramp that up to 5 thou because the simulation time would be much quicker rebuilding that updated stock. So it's all based off of how you guys want it to look in here. Any of the accuracies that you set in your Solidverify do not affect the G code at all. It's just basically how fast that model will load, as well as how accurate it's going to be.
Yeah, that's a really good point. It's a trade-off between how fast the simulation is versus how accurate the simulation is. So if you make that accuracy a little coarser, like Kevin said, if it's 5 thou, this will really simulate real quick. You'll see the tool moving around, but it won't look as sharp as if we made this a little tighter, and then you can actually see very tight corners, very smooth arcs and such, but you're waiting for that to be developed. And it basically just goes down to this value here is the building block that we build this STL using. So there's little tiny triangles of that size. Each edge of that triangle is that length. So the tighter you make this, the smaller you make this, the more defined you can make this, more elements that get made into that STL. But you're waiting forever for that to be developed. Yep. You're waiting for that to be simulated.
Mark, if you zoom in on kind of right where you just were, zoom in right on that radius, you guys can see not on the orange, but the next level up, you can kind of see how it's getting faceted in there. Now, if Mark was to change that to a 1/10 accuracy, you don't have to do it, Mark, but if he changed that to a 1/10, those facets would go away. But like we were saying, it's going to take longer to load up the model, and this is more dependent on your graphics card than anything. So if you guys have a really high power graphics card and processor speed, then you won't notice any difference here. But on some of the lower end computers, you will definitely see a slow down because it's rebuilding, like Mark was saying, the STL file for you guys.
Okay, now it doesn't really show up here. Actually, well, let me show you one last thing here. So if we bring the tool on screen, I just want to finish up these icons here, but there is something on the mill turn side, the mill turn module, that actually gets expanded here. But let's take a look at just real quick here. Here's your 3D tool representation. I can hide the tool, and I can hide the holder. So just visual stuff. But on the mill turn side, that actually gets expanded. So let's just bring up a quick mill turn part. And this is something that I've covered in a tip and trick video. Let's bring up my old friend over here with the SolidCAM logo on it. Translate that into 2020.
And for those of you guys that are watching while Mark is pulling this up, if you guys are not on 2020, definitely go to the site and grab it. We're on 2020 SP1 right now. It's been a great build. So
in the simulation, especially for these turning tool paths, there is the turning simulation. Just shows us the profile. We can see the tool going through and doing and whatnot. Now, in Solidverify, we can actually get something very similar. You can see there's some extra icons here, and this 2D one gives us that similarity there. That just gives us that profile. Let's see, get a better view over like that. Now, that's not necessarily the turning view. That's the turning view right there. Let me angle that so we get some shading. So that is actually the cross section down the middle. So we can see the turning tool paths, but using Solidverify functionality, right? In addition to that, since we're already looking at, let's say, the full part, you can see your color coding there is assigned to each tool as well. We can actually do half view. So if you want to see what it looks like when you do your bores and such, you don't necessarily always have to go to the turning tool path, the turning simulation to see this. You can use the Solidverify and get that same functionality.
Mark, what do I have to click if I want to see my feeds and speeds and cycle time?
This icon right here, show data. And I'm surprised I didn't have that already on screen, but there it is. If we expand this a little bit, In your Solidverify, you can actually see all your coordinates. So in this case, we're just doing mill turns. So you've got X, Y, Z, and then my C angle. But again, based on whatever module you're in, whatever post you're using, you can see the different coordinates there. Your feed, your speed, your step actually lines up with your posted G code. So if you've got, let's say you got N codes in your G code and you want to follow along on your second screen, or if you've got a printout or something, then you can take a look at your step, and that's actually the line of code that you're on. Cycle time, as you see there, and then any other additional information in this case, if computation is engaged or
not. Now, one thing when you guys are in Solidverify, as Mark's going through these buttons, is one that I very commonly recommend is there's the one that looks like a little rocket ship. This is, if you go to run your Solidverify and you're not seeing your previous operations that you have done, that means that updated toolpath has been turned off. So if you guys turn on, I just call it the little rocket ship. If you turn on that rocket ship, then it will show any previous operations that were done.
So this is the third operation in the list, but with that rocket ship icon turned off, I'm not seeing the turned portions. It didn't get faced and didn't get turned. So when I go to run this toolpath, it's not really truly representative. Those would actually have already been turned. If I turn this on, and then when we exit and we go back in, now the stock has been updated to show the facing and the turning. That basically just updates your stock.
Perfect.
And as we saw in a previous video, let's just recalculate down to the, where's my cutoff? I don't think I do part off on this one, but we were talking about in a previous class, previous SolidCAM Live, where you might have multiple solids on screen. This icon right here is what we used before. You can actually see all the stock, all the different solids that get represented after the turn path, after the tool path. So if you do a part off, let's say in the mill turn, or like we saw with one of the first classes, when you actually generate a slug and you want to get rid of that solid on screen, that's this icon right here. It basically just gives me a list of all the solids on screen, all the separated solids, and I can delete or leave on screen whichever one I'd like.
Now, as long as we're in the simulation phase, for those, I see a lot of guys, and I get this question quite a bit, and I even do it myself, is, you know, we have all these different simulation modes. We have rest material, Solidverify, turning, host CAD, 3D. A lot of these ones, me personally, I don't use often at all. Let's, Mark, let's show them where we can turn off the unused ones.
That's a global setting, right?
Yep.
So let's exit out of the part. Go Tools, SolidCAM, SolidCAM Settings. Let me just bring this over. So that would be in your toolpath simulation, simulation modes. And then like Kevin said, if you don't end up using 2D, 3D, quick Solidverify, if you're really only ever interested, you don't even have a machine sim, you can turn all these off. And then when you go and click on simulation, the only tabs that show up are the ones that you've left behind.
And as long as we're in this one, the section right above it, where the default simulation option. So what this will do is anytime that you exit out of a simulation and hop back into a simulation, it's automatically going to go to the host CAD. Now, this is great if you are running very heavy parts where the Solidverify does take a while. So I like to use this one more just because if I use the option to remember last simulation, and my last time I simulated was a machine sim to make sure everything was good, I don't need to play and load up that entire machine sim. I just want to go right to host CAD just to get a quick preview. So that's another nice feature in there for you guys.
Yep, absolutely. Especially if you're really just going to the machine sim maybe at the last stage. Maybe you've programmed the entire part, you've got all your tool paths, and now you just want to see it in one go in machine sim, because your machine sim is probably a larger file, takes a little bit of time to load. You probably just want to check it in HostCAD every 2 seconds, whatever, sanity check. But at the final, before you post the code, you want to load up that more complex model. You don't want to have to keep going back to it because this option is checked. You want to go to HostCAD first and then decide when you want to go into machine sim.
Yep. The only other thing that I can think of for, since we're going along the lines of simulation, Mark, is the Solidverify and the by fixed steps and by fixed frames.
Yes, okay, so let's go back to the 3D model. So what Kevin's referring to is just a setting in the Solidverify, and it's just how that toolpath is represented. Let's just wait for this to load, and we'll just do first toolpath, Solidverify. And then setting, general.
Yeah, so when you guys, on a particular part, maybe you would like to see every single G-code line being shown. What we'd want to do is switch this over by fixed step. And right now it's showing us every 15 lines of G-code, but you could set that down to every single line of G-code if you just put a 1 in there. Now you can set this up to go all the way from 1 all the way up to 999. And this will definitely affect your speed too. So if Mark changes this up to 500 and simulates it through, it's going to simulate through much faster, but you're not going to see every line move that's going on.
So the tool jumps around a lot, but that's because that's every 50th line of code, or 500th line.
500, yep.
Whereas if we jump out and jump back in, and obviously we don't have to run it that far, but let's reduce it down to something.
Let's do every 1 line and see all.
Let's live dangerously. Let's go every 1 line of code.
You guys can definitely see the difference. We wanted to play it all the way through, but now it's visually showing us every single line of code that's going on there. And obviously you can see it's going to take quite a bit longer just to show that. So you guys do have that option there as well.
I guess probably have to jump out, jump back in sort of thing to show that. But the other option, the one above it, is just frames per second.
Yep.
So same thing. Let's see. No other questions? All right.
Hey, do we have any questions, guys? I know we're kind of covered quite a bit here, just more along the lines of the Solidverify and some of the simulation settings. We either blew them away or we put them to sleep.
All right, let's see. This is back here. Now, there's one that I have never really played with myself, and I noticed we saw this in a more recent webinar, region of interest. You can actually reduce down the, I think you can you drag it? I guess you can't drag it. But basically, this is the focus of the toolpath, and I've never really touched this one myself, so I'm kind of freehanding it here. But let's see if we do -2, -2, -1. So let's say we set that region of interest there. It just reduces the size of not the stock, but just the visual. So if I run this through, I'm really just only looking at that bit of the stock. So that can sometimes allow you to increase that facet tolerance or decrease the facet tolerance, increase the accuracy, but not require it to actually compute the whole thing. You can see that it's really just doing the area that's there. So I can kind of refine that and just see that one little area if I really want to get that tight visual.
And with the simulation modes, all simulation modes inside SolidCAM, you guys, for those of you that are using a 3D Connections space mouse, it is fully supported in there as well. So it's a great tool. Instead of having to move stuff around using a mouse cursor and all that, you can actually use your 3D mouse for inside the simulation.
Yeah, and to show that off, I don't use mine that much, but here we are. So there is about 5 minutes left. No other questions. So this is a training session we're doing every day until the 1st of May, and it's open to any questions, any suggestions you have in terms of topics. If nothing comes up, Kevin and I will probably just have something that was interesting that day, maybe through tech support, or if I see something on Facebook or something like that, we might talk about it. But if you have any questions, any topics you'd like covered, I'm actually going to put in the chat section my direct email. And some of you actually probably already have this because we've done training before, or you've attended the previous SolidCAM Live training sessions, but that's my direct email. So if you have any questions, you can always send that to me. If you have Kevin's email, because he's Mr. KevCam, you've got his email as well. Any previous topics that we haven't covered yet that we've received, they'll probably come up in the next couple of sessions. But this is a good example of the kind of online training we do for our customers. So if you're interested in getting more direct personal training, contact the salesperson for your area, and you can get direct one-on-one in a GoToMeeting training session with myself, with Kevin, with some of the other trainers on our staff. And it's all based on your availability. So if you are on the West Coast and Kevin and I are on this side of the country, we can still address your time zone. So any hour, anytime you need that help, we can schedule a training session for you. And it could be on any topic that you specifically are looking for as well. So it doesn't necessarily have to be something like this. It could be your specific part. We can go over training on part-specific help, strategies, using different toolpaths, how different toolpaths work, that sort of thing. And in addition to that, a lot of people, if they're not familiar with SolidWorks, we actually offer a little bit of that as well. I mean, we need to know how to use SolidWorks to do this software. So if you have any of those kind of questions for this training session or your own personalized one, you can always ask us those as well, and we can try and cover those as well if we have time. So no other questions. Okay. Well, what do you think, Kevin? Anything else you want to cover on today's topic or anything else?
No, I think we basically covered everything that I think that was useful for everyone. But like Mark said, if you guys do have more ideas, and then we'll definitely, I know Jake popped over one, so we'll probably be covering that tomorrow for you guys.
Yep.
But any ideas, let us know what those are, and we'll get those addressed.
Let's see, the last question there. How is HSR better than iMachining? iMachining has varying fees and speeds. How is HSR useful? HSR, I guess since we showed HSR, we should just talk about it real quick. HSR is also a model-based 3D model toolpath, 3D toolpath. It's based off the target, or you could always choose other additional solids if that would make sense. But how it differs is it's got different movements of the tool. So iMachining obviously is iMachining. It'll do the tricoidal movement, whereas HSR, you can tell it to specifically do a contour style or a, let's just do the contour style here. So we take a look at it from the top view. You can kind of see that it's following contours around the part versus if we do linear, then you choose which direction you'd like to go. You can kind of think of it like a three-dimensional pocketing toolpath. It just looks at your solid rather than choosing chains. But in terms of feeds and speeds, you will plug in your own feeds and speeds. This is still a toolpath that requires that level of user input.
And
I don't know if that answers the question.
The one thing I do like, HSR is all based off of constant step over, where iMachining is based off of scallop height, and where you'll get better results using iMachining versus HSR is that scallop throughout the entire part is going to be the exact height that you specify. So when you come back to do a finishing tool path, you don't have a uneven load on that ball end mill to get a better surface. So with iMachining, you'll have that smooth consistency. That scallop is always going to be the same height throughout the entire part, where on constant step over, your scallop may be much smaller on a more vertical surface, or I'm sorry, on a more horizontal surface. So you're going to get scallop heights that are constantly varying, which will lead to different finish results when you're going to finish that tool off, or that part off.
Yeah.
So.
And then in another more practical sense, HSR probably calculates quicker than 3D eye machining.
Yes.
in certain instances. Although there is in the future, I don't know if anyone said, actually, you know what? No, I'm not going to say. I think we'll save that for a future KevCam. I think you're going to be talking about, if you know what I'm talking about, Kevin, the future version of HSR is coming up.
Yep. And what we'll do, Edwin, is we'll go more into the detail about this in another SolidCAM Live. So I got your question saved out, so we can add that to one of our SolidCAM Lives to do a comparison so you guys can see it.
Yeah, absolutely. Okay, I guess we'll leave it there. So tomorrow's session is also at 2 p.m. Eastern time. If you sign up for this one, I think it automatically signs you up for the other one. If not, you can always go to our website, solidcam.com. In upcoming webinars, you can sign up for the future webinars. Let's see, last question, is there a future? Yeah, okay, we'll talk about that. We'll talk about the future versions of any of these toolpaths in the future. We got many of these. Like I said, we're doing one every day at 2 p.m. until May 1st. So if you haven't signed up for all of them, you can go to the website, sign up, and it should give you a repeating link that you can use every day. So we'll end it here, and we thank you for your time. During this period, everybody stay safe. If you're essential, then we thank you for your essential work, and I will talk to you guys tomorrow.
All right, thanks, guys.